Yes, hello, hi. Welcome back to EDUHUNT IIT Foundation classes. This is Sukumar, your chemistry mentor. See, we are in 6th class Foundation Chemistry. The chapter name is Elements, Symbols, Ions, Formulae. Yeah. See, in the previous class, I explained a topic called Valency. How many of you remember that? Have you watched that video? Yes, I hope so. See, what is valency? I explained there. What is valency? Valency is nothing but combining capacity of an atom, element. Okay? Valency is nothing but combining capacity of an atom. That means, what is the capacity of an atom to combine with other atoms? You know, carbon is combining with 2 oxygens. So simply CO2. You take CO2 molecule. Okay, in your imagination you take CO2. What it means? Carbon combined with 2 oxygens. So now anyone can understand that carbon has a capacity to combine with 2 oxygens. Yes. If you take another molecule like SO3. SO3. Okay. By looking at that molecule, anybody can understand what? Sulfur has a capacity to combine with 3 oxygens. Yes. So, if you look at chemical species like molecules or ions, you will notice that different atoms has different combining capacities to combine with other atoms. So, valency. Combining capacity is nothing but valency. Now, how to understand or how to identify the valency? How do we know a particular atom is having particular valency? Yes, in the previous video I explained that. How? Let me revise a little bit so that we have a proper continuation in this video. The combining capacity is nothing but number of hydrogen atoms or the number of, listen carefully, you take an atom and what is the combining capacity of that atom? Combining capacity of that atom is equal to number of hydrogen atoms or number of chlorine atoms or double the number of oxygen atoms with which this particular atom can combine. Okay? This way we understood what is valency. But let me tell you, this way of defining valency is a old method. And it has some limitations. Okay, it is not applicable everywhere. Like if you are going to determine the valency of an atom only by the number of hydrogens or number of chlorines or number of oxygens attached, you will get lot of exceptions or wrong answers. I explained that also in the previous video. So what I am saying is, if you didn't have watched that video, the first video of valency, introduction valency, so please watch that video first and then come to this video. Okay? Yes. Now in this particular video, I am going to explain the modern way, the best way, the modern way of defining or understanding combining capacity. Okay? Modern way. Modern method. Okay, I'll say modern method. Modern method for what? For what? Valency. Okay? And it is quite simple. It is quite simple, or it is the best way I can say. Okay, what is this? First let me define that. What is that? Valency is equal to number of electrons lost or number of electrons gained or number of electrons shared by a particular atom in the formation of while combining with while ane kada by particular atom to combine with other atoms, to combine with other atom or atoms. Okay, simple way of understanding what is valency. See, let me explain you in detailed order, in detailed manner. See, first of all, if we think why an atom combines with other atom, simple question, na? Why any atom, why a atom combines with other atom? Now the simple answer is to get stability. So first of all, why an atom combines with other atom. Okay, it's a simple obvious question. You can ask your teacher, right? Why an atom combines with other atom? So the simple answer to this will be to get stability. To get stability. Okay, to get stability. Now then what is the next question you can expect? To why an atom combines with other atom to get stability? Okay, which atom is stable, which atom is not stable? This is crucial point. Generally, I hope you know, in atom there is a nucleus at the center, and electrons are revolving around this like this. In the upcoming chapters, you may study atomic structure. There you will understand this is the nucleus and electrons are revolving in particular paths called shells. Okay, now you can say this as a first shell, second shell, third shell. Like this, different atoms have different number of shells. Some atoms have only one shell, 2 shell, 3 shell, 4 shell, 5 shell. Like that, different atoms will have different number of shells. But the point is, every shell has some electrons. Every shell has some electrons. But the point is, generally, see, this is the outermost shell, na? This is the outermost shell. Outermost shell. This is called outermost shell, or simply you can call it as valence shell. Valency shell. Valence shell. Outermost shell, other name called valency shell. This is quite important. Why? Because the number of electrons in the valency shell, is very important for the stability of a particular atom. So generally, it is studied, it is observed that if the atom has 8 electrons in the outermost shell, that arrangement is called octet configuration. Sir, what I mean by configuration, sir? We don't know configuration. Imagine, configuration means arrangement. Configuration means arrangement. Octet configuration means arrangement of 8 electrons, okay, in the valency shell. So in the upcoming chapters like periodic classification or further topics, you can understand why that octet is stable, how. But right now I am giving a little idea about the stability of an atom, because first of all I raised a question, why an atom combines with other atom? Why an atom combines with other atom? Simply the answer is to get stability. Now student may ask, like you may ask me, sir, which atom is stable, which atom is not stable, how we do know, sir? Yes, that's a good question. So generally you go by this concept like the stability of the atom in general, the stability of the atom is decided by the number of electrons in the outermost shell. Number of electrons in the outermost shell. In general, if there are 8 electrons, that atom is stable. Like that, there are some other arrangements also which give stability. For now, this is the major one. So simply, which atom is stable? If I ask you, which atom is stable? The atom with 8 electrons in the outermost shell. Then, sir, we don't know what is shell, sir. No problem. You know that there is an atom, and there is a nucleus at the center, and you know electrons are revolving around, right now? The path of the electron following is called shell. The path of the electron, shell. Okay, like that there can be many more shells. And we are talking about only last shell, outermost shell, towards outside. The last shell. The outermost shell is called Valency shell. And the number of electrons in that Valency shell gives stability. So 8 electrons generally give stability. Now the question is, normally this kind of stable electron number is not present in all atoms. You say, for suppose, if an atom has 6 electrons, imagine there is an atom which has 6 electrons in the outermost shell. Then what that atom will do? You tell me. What that atom will do? To get stability, it needs 8 electrons. But in the outermost shell, only 6 electrons are there. Now what that atom will do? That atom will gain 2 electrons. Right? That atom will gain 2 electrons from other atom. Okay? Yes. Similarly, for suppose, let me tell you. In the outermost shell, there is 2 electrons, and in the shell behind the outermost shell, okay, there is 8 electrons. Now you suggest something. What is the best possibility for this atom to get stability? See, there is 2 electrons in the outermost shell. If it gains 6 electrons, then what happens? It will get 8 in the outermost. But gaining 6 electrons, gaining 1 electron, 2 electron, 3 electron, okay. Gaining 4 electron is difficult, more than 4 is highly difficult. So generally, gaining or losing 1 electron, 2 electron, 3 electron, that's more. Okay. Gaining or losing of 4 electrons is very rare examples. Okay, very less. Because it needs a lot of energy. So the better possibility for this atom to get stability is to lose these 2 electrons in the outermost shell. So this atom will lose the 2 electrons. So when this electrons lost, when there is no electron, no shell. When there is no electron, no shell. Then the outermost shell becomes this shell. Then there is 8 electrons in the outermost shell. That's how this atom got stability. Right? So by all these examples, what I am trying to explain you is, an atom combines with other atom to get stability. And what is stability? Having some particular number, 8 electrons in the outermost shell is stability. But usually atoms are not having that number of electrons. So atoms, what it will do? They will lose electrons sometimes, they will gain electrons sometimes, and they will share electrons sometimes. Okay. So to get stability, sometimes atoms will lose electron, atoms will gain electron, and atoms will share electrons. So simply, how we can measure the valency now? By that number only. The number of electrons lost, or the number of electrons gained, or the number of electrons shared by an atom to bond with other atom. For suppose there is an atom, okay, which is going to share one electron with other atom. There is an atom B, this electron belongs to A atom. This electron, okay, and this is, let me take this, what I mean is, this electron belongs to this atom and this electron belongs to that atom. Now what these two will do, they will share this. This pair is shared between them. Now talking about A, how many electrons this A has shared? 1. So its valency is 1. Its valency is 1. Then talking about B, how many electrons this atom shared? 1. So both have valency 1, valency 1. That means the combining capacity of A is 1 and the combining capacity of B also 1. That's why 1A combined with 1B. Okay, let me take another example like A has 2 electrons, B has 2 electrons. Now they shared these 2 pairs. Okay, now how many electrons this A has shared? 2. So its combining capacity is 2. How many electrons this B has shared? 2. Now the combining capacity of B is 2. So both have same capacity. So the combining capacity of A is equal to combining capacity of B. That's why 1A combined with 1B. 1A combined with 1B. Now let me tell you one example. The combining capacity of A is 2. So it can share 2 electrons to get stability. Okay? And why the stability comes and how it comes, I explained already. And imagine there is another atom C. It has to share only 1 electron to get stability. Okay, now tell me, this has to share 2 electrons to get stability and this has to share 1 electron to get stability. Now what? Its combining capacity is 2. Its combining capacity is 1. So its valency is 2. Its valency is 1. Then what happens? So actually the combining capacity of A is equal to double the combining capacity of C. Then what happens? 1A can combine with 2C. How? This electron shared, this electron shared. The combining capacity of A is 2. Combining capacity of C is 1. It means what? Combining capacity, the valency of A is double the valency of C. Na? That's why 1A combined with 2C. This is how things will go on. Okay. So let me take some real examples. See, in a compound, sodium has lost 1 electron. You know, I explained their cations. Sodium has lost 1 electron to form a compound. Here the valency is 1. Here the valency is 1. Right? The charge, you can see the charge. Okay. For suppose calcium has lost 2 electrons. Calcium has lost 2 electrons. Okay. So its valency is 2 plus. Are you getting this? So this is how, by looking at the charge on the species, you can identify the combining capacity, right? In the case of anions also. For example, Cl minus. It means what? Chlorine atom has gained 1 electron, okay, to combine with others. So sodium has a combining capacity of 1 and chlorine has a combining capacity of 1. So the compound you can expect between them will be Na plus Cl minus, the opposite charges, right? When there is opposite charges, there will be an attraction. That attraction is nothing but bond, okay? So they are attracted towards each other. So that attraction is nothing but bond, right? So what we can understand here is the number of electrons lost or the number of electrons gained or the number of electrons shared by a particular atom to combine with others is nothing but the valency or combining capacity. Okay, let me explain this. Let me explain this modern way of defining valency with a few more real examples. Okay, let's start.